In this video, I want to give you an overview of the confidence interval formula. So this is where we're going, and there's a lot of pieces involved, but I want to show you kind of the big picture of where we're headed. So this is the formula right here. P hat, which is our sample proportion, 60% in the example of healthcare, plus or minus, that's the plus or minus part. There's something called a Z star, or a critical Z score. And this is what depends on the confidence level. So this number will be different if we have 80% confidence versus if we have 95 or 99% confidence. And these are some of the most common confidence levels that you'll see. Then this might look familiar to you. We had in the last section the formula, the square root of PQ over N. And that was the standard deviation of the sampling distribution. So this is using that same formula, but we don't know our population parameter. So now we're using P hat, which is the only value we know, since the reason we're taking a poll is we don't know the population parameter. We're going to substitute P hat in there and Q hat, and also you can see it includes our sample size. So let's try it for that healthcare example. So P hat would be 0.60 plus or minus, I'll tell you the Z star for right now and we'll show you how to get that. It's 1.96 times the square root of P hat again, which is 0.60. Remember, Q is the complement of P. So if P is 60%, Q is 40%. P hat, Q hat, divided by our sample size, which was 1754. Okay, so I will just bring the 0.60 plus or minus down here because the website said their margin of error was plus or minus 2.7. And we're going to calculate just this part and see if we get the same thing or not. So 1.96 times the square root, and then you can just punch this in all at once. 0.6 times 0.4 divided by 1754. That will follow the order of operations because it's going to multiply across, then divide, and then take the square root. Okay, so I'm getting, move it over, well, let me write it first, 0.229 plus or minus 0.0229. So if we change that to percentage, 60% plus or minus 2.3 percentage points. So if we use this formula, we actually get a slightly smaller margin of error. I don't know exactly how they got the 2.7. They might be using a slightly more complicated technique because they did some other things. We're going to be using this formula right here. So it should be close. It's fairly close. So that's what we'll be doing. And in the next set of videos, I'll be building up all these pieces of the formula so you can understand how it works. Okay? I'll see you in the next video.